Hi and welcome to a new video. Today we will talk about the current X299 platform from Intel and all the problems I discovered during the last weeks. So starting with last week, I started testing CPUs for Caseking internally so we can find what kind of clocks we can offer for pre-tested CPUs and also what kind of mainboards we would use for our systems. And during that testing, I figured out that basically I cannot use any mainboard because all those mainboards are not properly designed. The question is this just the mainboard's vendor's fault or is it probably also Intel's fault? I think it's 50-50. Intel's fault probably because they pulled in the launch from August to June and gave the mainboard vendors zero time for developing proper products. And that's the result what we have now. So I started testing. I have the Gigabyte Aorus X299 Gaming 3 motherboard. And that was the first board I tested. And what I did was I used the 5 GHz CPU I showed in one of my previous videos because I knew what kind of voltages and clocks I can reach with that CPU, and I wanted to check how good those mainboards are. So on this board, I attached a thermocouple on the VRM heatsink and also a thermocouple on the back of the PCB behind the VRM, so I could figure out what the VRM temperature would be. And I set the CPU clock to 4.6 GHz and 1.25 volt, which is probably something an average CPU could do if you cool it very well. I used the X299 Kraken AIO for cooling, and the result I had was kind of surprising because I couldn't do it. So after maybe 10 or 15 minutes, the VRM here hit a temperature of 84 degrees Celsius. And the VRM on the back, like the backside of the PCB, had a temperature of 105 degrees Celsius. So if we take into account that there is still the PCB in between, and then we have some kind of measurement tolerances, I would assume that the VRM temperature was probably 120 to 130 degrees Celsius. And that was with Prime 95 non-AVX load. So if we would use AVX, it would be even worse. It was at 4.6, 1.25 volt. And I know that the CPU can do 400 megahertz more. So yeah, that's something I did not expect. So the problem is all those mainboards I have in front of me have a very bad heatsink design. The thing is, if I take off the heatsink of this board and just put a fan over it, a 120 millimeter fan, then there is no problem whatsoever. The temperature of the VRM drops to like 70 degrees Celsius. So we're, I don't know, like 40 degrees less without the cooler compared to with the cooler. So I'm not sure if this is really a cooler or if I should call it like a heat insulation or something like that. The thing is, those blocks on those boards, they have zero surface area. They're just there to, I don't know, heat buffer something. Another issue we have is that on a lot of boards which we currently see on the market, they only have an 8-pin connector. An 8-pin for X299 Skylake CPUs is not enough. If we run the skylake-x 10 core at 4.5, 1.25 volt, the CPU will pull like 300 watt. And pulling 300 watt through one 8-pin connector is not going to work. I attached a thermocouple on the 8-pin connector, which goes into my PSU, to measure the cable temperature. And the cable temperature was 65 degrees Celsius. And that was in an open test bench area. So now imagine you would put all this stuff into your case, in your closed case, and you have a lot of cables in the way, and you have maybe a bad airflow in that area, and maybe it's summer and you have like 40 degrees Celsius in your case, which should be quite common with air-cooled graphics cards. Then I don't know, you have like 80, 90 degree on your cable. That's probably very close to your PSU or your cable catching fire. So from my current perspective, I cannot recommend a single mainboard that has only an 8-pin connector if you want to overclock. So if you want to overclock your skylake-x CPU, stay away from any mainboard that has only an 8-pin connector. It doesn't matter if it's MSI, Gigabyte, Asus, ASRock. It doesn't matter how good the VRM is designed. If you have only an 8-pin, stay away from it. So let's go over to the Asus Prime X299A. And this board was actually even worse than the Gigabyte board, even though it has an 8-pin and a 4-pin. So 8-pin and 4-pin should be fine for power delivery, but the VRM cooler is ridiculous. So after, I don't know, 10 minutes, the VRM cooler hit 86 degrees Celsius, and on the back I had 96 Celsius. I'm not really sure if the probe on the back was positioned correctly, because usually there should be a higher delta between the the VRM cooler and the back of the PCB. So I'm not really sure, but considering that the VRM block had 86 degrees Celsius, that's not a good sign. And after running 5 minutes of Prime 95, this board was also throttling. So it clocked down from 4.6 to 1.2 gigahertz to maintain specs. So the temperature on the VRM cooler would drop and the MOSFETs would cool down a little bit. And after, I don't know, like 10 seconds, it clocks back up. It gets hot again, clocks back down, and we have all this thing for, I don't know, forever. Next board I tested was the MSI X299 Pro Gaming Carbon, and this board was temperature-wise a bit better because it just simply throttled earlier. So I measured 75 degrees Celsius on the block, 91 degrees Celsius on the back of the PCB, and then it also throttled from 4.6 to 1.2 gigahertz. So yeah, I'm really not sure what to say about this. Sometimes I'm questioning myself, like, are mainboard vendors testing these boards before shipping, or like, I really don't know. How can you design a mainboard like this and you have a block that cannot dissipate any heat, you have zero surface area, and you cannot overclock at all? Like, is this only meant for spec? Because if it's only meant for spec without overclocking, I mean, what would be the reason to buy a skylake-x? If you have an X CPU, X suffix CPU, you would overclock it, right? And I mean, of course, those are kind of entrance boards to X299, but they're still 300 euro. And for 300 euro, personally, I would expect that you at least have some surface area on the VRM cooler so it can maintain the temperature. So yeah, not really sure what to say. The funny part is if you take off the VRM coolers on any of those boards and just put a small 120 millimeter fan above the VRM, it's perfectly fine. You have like 60 or 70 degrees Celsius VRM temperature. So the VRM itself is not a problem. It's just the design of the heatsink that is very bad. Probably also the thermal pad is very bad. It could be that if you replace the thermal pad to a higher grade one, that you can bypass the throttling for, I don't know, another 100 megahertz, but that's probably it. So from my current perspective, if you're looking to buy a skylake-x platform, you should probably wait another month, maybe 2 months, so the mainboards are properly designed. Maybe we can see some high-end mainboards that are pretty good for overclocking. I know internally from Asus that they also figured out this issue and they kind of recalled their heatsink designs from the Apex and the Rampage 6 Extreme. So what we have seen during Computex will not be the final boards. They will have proper heatsink designs ready in like a month when the boards are ready. At least they figured out the issue and working on it. That's a good sign. But from the current point of view, I cannot recommend any X299 motherboard for proper overclocking unless you do water cooling on the MOSFETs. So I hope that the mainboard vendors see this video and they start thinking over how they design their products and go back to designing proper heatsink instead of just doing design stuff, because this does not work. Okay, so I hope you liked this video, and if you have any kind of questions about the X299 motherboards, about the VRMs or whatever, put it down in the comments. I will check it and reply to you guys. Otherwise, have a nice day and see you soon.